Good morning. We are about to start our webinar today. I'm Serena. Today we are going to talk about an application, a cross application between the EMG and another device that most of you already know, that is the GWALK. As usual, for the one of you who is the first time attending to this kind of webinars, of lessons, I ask you to give me a feedback in case you have any issue in the audio feedback. We will start having a first part of the presentation competing on a PowerPoint presentation, and then on the second part we are going to switch on the real application. So we are going to perform a small acquisition here in our lab in order to show you practically how the exam can take place. First of all, it's very important to understand why in the last 20 years clinicians and researchers are so focused on the importance of the analysis of the walking pattern. For sure, it's something that we do every day. So walking is a very common movement. It's something that we do without any involvement, particular involvement, but we do very naturally. But it's really important as a movement because it can give us the information about the state of health or even the age of a person. So, for example, we can understand from a particular walking pattern if the person is getting older, so maybe the walk will be slower, or if the subject maybe can start shuffle, or maybe if we look at a person walking, dragging one of their legs, it can be maybe an affection due to a stroke suffered by the patient, or an injured knee or an injured hip can define a huge asymmetry in the walking pattern. So as I was telling you, the clinical research at the very first beginning recognized the importance of the gait information. Of course, this need from the research field switched over the years over the clinical and the medical field, in which, of course, the gait information is important, but is rarely used as an input because it's not based on quantitative evaluation. So what is the need right now is to quantify the person gait, and having a very strong, this is going to be a very strong clinical need. Of course, the way to analyze the walking is very different, and it's huge in the application because due to the importance and the complexity of this kind of movement, we can investigate and understand if something is going wrong on the subject at different levels. So we can analyze the special temporal parameters, we can go through the electrical muscle activity or the walking kinematics and kinetics. Of course, all these levels can be used, can be analyzed, can be assessed as a standalone solution, or we can make an interference between them and try to make a cross-analysis between all the parameters and levels that we can find. So all this information, as I was telling you, can be combined in order to get a better assessment of the patient. And this is the reason why BTS has created different integrated solutions in order to assess at multiple levels, in this case, the walking pattern. So, as usual, okay, after all this great discuss from where to start. And we create different levels. At the very first level, we have the BTS FREEWALK that we already spoke about in my last webinar. And at the second level, the topic of this today's session, the BTS FREEWALK. BTS FREEWALK is a system created for a functional evaluation of walking, providing objective and quantitative data related, in this case, and focused on the muscle activity. So is the connection between the very focus that will be the dynamic EMG analysis, normalized and normalized by the special temporal parameters detected by the G sensor. So in this way, we have the conjunction of two different levels, the EMG activity and the special temporal parameters. In this way, what is really important is that with BTS FREEWALK, we can make a gait analysis everywhere. So we can do it in the lab, we can do it in the studio of the clinician, we can do it in the hospital ward, in the gym, wherever we want to take it place. Because the technology that stands on the base of the BTS FREEWALK is wireless device. So we will have wireless probes for the EMG connection, for the EMG detection, and wireless G sensor for the special temporal parameters detection. The patient is asked to walk at his natural speed, and at the end of the acquisition, the software processes the data and displays the report automatically. As you can see in the picture here on the slide, the sensor will be positioned as G-walk analysis, so on L5, and then we can go up to 8 probes to analyze the activity of the muscle, depending if we are looking at the distal or proximal analysis. We can decide to make a full leg analysis with 8 channels, so we can choose 4 channels for each side, or we can decide to focus on the distal or proximal district and analyze that. Of course, we still have the normal classes of reference, so depending on the age, we can compare which is the normal activity in terms of timing of activation of all the muscles analyzed. And we get, in this way, we get the chance to monitor the subject progresses, both in terms of special temporal parameters and both in terms of EMG activity, because you still need to remember that even if the special temporal parameters are correct or incorrect, we never know until we don't go deeper, which is the real cause of this distance between the normative band and the patient pattern. So, as I was telling you before, we will switch on the practical session. The acquisition in our case will be applied over 4 muscles, 2 muscles for each side. Just because in this way it's going to be quicker. We are going to analyze the tibialis anterior and the gastrocnemius medialis. So we will place 2 probes on each side. And then the subject, as I was telling you, will be asked to walk everywhere inside the Bluetooth range, because the restricted one will be the range connected to the G sensor that will be positioned on L5, like during a BTS FREEWALK test. Okay? Just to close the PowerPoint presentation, this particular application is a valuable help in the daily activity of all specialists, and can be applied at several levels, so physiatrists, orthopedics, neurologists, and physiotherapists. So anything that involves a motor disorder in the gait pattern can be evaluated with BTS FREEWALK. It's not invasive, can support the diagnosis, can define the treatment to be performed, or can monitor the follow-up of a certain treatment already applied. Okay, so here is the sensor, so the one that you already all know. I don't know if you already see the new one, that is this one. And as G-walk analysis, we are going to place this sensor on in the belt in this position, with the connectors up, with the label facing outside, right inside the belt, and closed in the way that the sensor is not going to move at his own movement while we perform the analysis. On the other side, we will place these probes on the muscles. These are the new probes. You can see that we changed the shape, and we changed the way that the probes are going to be activated. Right now, we just need to swipe the probe on a magnet, and the probe will be active. These are our new probes. I don't know if you already saw them. I placed probe number 1 and number 3 on the right side. So number 1 will be on the tibialis anterior, and number 3 will be on the gastrocnemius lateralis. And now that all the probes are connected, okay, we can start. I will type the walk test. I click on acquire. The interface that we have is still the same. I just look at all channels. I reduce the scale. And when I want to start, I click on start recording. and my colleague can walk. Okay, she stopped. I can stop the acquisition. Okay, thank you. Here you can see that we have several lines on each EMG signal. Here on the labels you will have the legend of all the instants detected on the EMG trial. And as you can see, we choose to use a protocol in which each signal will be EMG signal 1, 2, 3, and 4. In this way, we can apply this protocol to every kind of setup of muscles without having any problems without having any problems about creating a protocol for each setup of muscles. So we save the data. We still have the chance to add some notes, and we go back to the software. As usual, here we will detect the same EMG signal that we just saw. So here there are all the instants detected. We select to include the normative band for the walking, and we choose this protocol that is BTS FREEWALK 4 channel. Okay, I don't think that you see the screen. You should now. Okay, perfect. We make the association between the trial, the information of the patient, the normative bands that we just select, and the images needed for the report, and we click OK. You can see that everything is automatical up to the moment in which we need to say to the computer at which channel we have which muscle. As I was telling you before, EMG number 1 is tibialis anterior on the right, and so I click OK. EMG number 2 is left tibialis anterior, so I click OK. EMG number 3 is the right gastrocnemius medialis, okay, and EMG number 4 is the left gastrocnemius medialis. Each label can be edited, so we can modify each name, and this is the reason why we left the general name of each channel in order to detect every kind of muscles, and we just need to change the label. So we click on OK. The report is automatically generated, and clicking on View Report, we have the preview of the report just printed. It takes a while to charge all the information. Here you can see that we have the surname, the name, the pathology, the date of the session, and so on. Here you can see that we have the information of the temporal parameters: stance phase, swing phase, stance time, swing time, stride times, and cadence, compared to the normative band here on the side. Then, page number 2 takes a while to charge. You can see that we have a last graphic that is empty that we can remove just in case. That is in case we decide to analyze 6 or 8 channels. The first channel is the right tibialis anterior, then we have the right gastrocnemius medialis with already imposed the dotted line for the jaw and the full line for the hip contact. And you have to remember that it's quite important that the very first step and the very last is deleted automatically by the software, and this is something that we kept from the GStudio software, because it's important not to consider a step that is not the regular and constant that we expect to be. So this is the reason why you see just these 2 lines instead of seeing all of them, because at the real beginning we decide not to keep it, and the real end we also have the phase in which my colleague was standing and not walking, in which we do not detect any step. Page number 3, sorry, we have the left EMG activity. So also in this case, you can see that the lines are different. So we detect more left steps instead of the right one. And at the very last, we have the activity normalized in the gait cycle for the right side and the left side, in order to see if there is any repeatability in the activity of the muscles. And as you can see, for the left side, we also have the standard deviation because, as you can see in this visualization, we have 2 gait cycles complete, from the heel strike up to the second one and the third. In the case of the right side, we have just 1 full gait cycle, so it's the one considered in the analysis as can be normalized. Of course, the longest is the walk, the most steps you can detect, so also the normalization can make more sense. And so the full line is the mean pattern, and the area surrounding is the standard deviation between all the steps. Then, at the very last page, you can see that we report normalized on the 100% cycle all the phases in the cycle in which every muscle of the lower limbs is supposed to be active. This has been done and not reported to the same graphic because we kept the general protocol application, in which we do not specify at the real beginning which is the muscle that we are evaluating. Because if we already do that, we can charge and overimpose here directly on the graphic the normative band. In case we do not know if the muscle will be the tibialis anterior or whatever other muscle, we choose to report everything at the very last page. In this case, you can see the tibialis anterior, for example, that has to be active at the very first 15% of the gait cycle, and then from the 45% up to the 100%. For the gastrocnemius medialis, is the normative band is reported here, and the gastrocnemius medialis is expected to be active up to the 50% of the gait cycle. So as we look here, we can see the same activity. So at the very first beginning, at the end of the gait cycle, and the same thing for the gastrocnemius medialis, in which I have the muscle active until I do not have the disconnection of the foot from the ground. Of course, this report can be printed, can be saved as a PDF. We can do wherever we want, as we always do on the EMG analyzer protocol. And so in this way, we have the chance to analyze the EMG during walking without using the foot switches that usually are not very comfortable, not to be wear and not even to be set up on the patient. So we choose to use an easiest system that can make the analysis quicker and can give the same results as we have for the foot switches. What we are going to have to this protocol, and is not displayed yet, will be the pelvic angles, as you can find in the G-Studio report. And it's going to be the next update of the BTS FREEWALK. Okay, so I wish you a very pleasant start of the week, and see you in our next session. Please check the webinar calendar online. Thank you very much. Have a nice day.